Okay. Hello, my name is Tan, and today I'm doing a Chapter 3 Thermodynamics original problem. So my problem states that a 8,000 liter cylinder is filled with 200 kilogram of R134A at a pressure, 134A substance at a pressure of 80 kPa. Find the specific enthalpy of the container. So first, I always start off my problem with, okay, I'm just going to underline this. First, I start my problem with the given. So we're given 8,000 liter, which is volume. So we know that the volume is 8,000 liter, which is, because this is asking for, this is in kPa, and we know that the table R34A is in meters cubed over kg. Let's convert this to meter cubed. So it's gonna, you divide this by 1,000, it becomes 8 meters cubed. Then we also are given the pressure, which is 80 kPa, and then we also have the mass, which is 200 kg. Okay, so since we're given the pressure, okay, so we have to convert this to a velocity, volume, average volume. So that's, we use this formula, V over M, so that's going to be 8 meter cubed over the mass is 200 kg, which is equal to 0.04 m cubed over kg. Okay, so now we have to ask ourselves, is this a mixture? To determine that, we have to use this one. Final volume is less than or equal to, oh no, not less than or equals, just less than initial volume and the final volume. So or sorry, and this is a specific vapor, this is the saturated liquid vapor. Okay, so since we're given the pressure, so I'm sorry, I have to compare these. So since we're given pressure at the table R34A, we have to look at the saturated refrigerant table A12, and this is, we're gonna be looking at the pressure 80. So we're gonna use all these values for this problem. Sorry. So when we look at this table right here, we know that the VF is this one, and then the VG is this one right here. So VF is 0.0007185, and then our V is 0.4, which we have, and then our VG is 0.23753. And this determines that we have a mixture, because this correctly states this statement. Then after that, since we're asked to find the enthalpy, we have to know the enthalpy equation. So enthalpy equation, so specific enthalpy equation, it's H average, which H is the enthalpy, is equal to H final plus XFG. So we know that this can be found from the tables. This table right here, table A12, and this can also be found, but we don't know what the X is, which is the quantity. What quantity? Quantity, yeah. Alright, so to find X, so we have to find X. This is the next step right here, to find X. We don't know what that is, so in order to find X, we need to know the formula to find the quantity. So X equals the average volume minus the final, and then over the VFG. HFG. So this can be found on the table. This can be found by using VG minus VF, which both can be found from the tables. And this is where we have, so X equals 0.04 minus, this was our VF right here, this was our VF right here, 0.0007185. Divide that by this right here, so 0.23753 minus 0.0007185, which comes out to be 0.16587. And from the table, we can see that these are all the units are m cubed over kg, so m cubed over kg. Oh, sorry, m cubed over kg. Okay, so now that we found x, this is our x value right here. We could then plug that back into this equation right here. Just then to find the H average enthalpy, or specific enthalpy. So we have H average equals the HF, which is of 80, which is this value, and we also need the HFG, which is this value. So we have now HF, which is 11.21. See, I see that 11.21 kj over kg plus x, which is 0.1659. I'm just gonna round it. M cubed over kg. Then you multiply by the FFG, which is 220.25. And plugging that into the calculator gives me 1 plus 5, which gives me, this is I got my calculator, 260, which is, so H average will equal 267.99. So we have kg clean. This last one was also, I think, kj over kg. So once we have all these values, it becomes 267.99 kilojoules over kilogram, because this all enthalpy are in kj over kilogram. So this will be our answer right here when asking for specific enthalpy. If this question asks for anything like, if this was given, this value could have been given in m cubed instead of liters, sorry, at a pressure of 80 kp. If this was giving us something like temperature, then we'll look at table A11 instead, because it's temperature. But since this is giving pressure, we're looking at table A12. So yeah, so first, yeah, so just always go through these steps right here and just try to follow it step by step, and then you come out with the answer, whatever it's giving. All right, thank you. And here's my problem again.